In the words of the fast stereotypical Italian plumber, here we go! Daily quiz. Yeah. All right. We have a table that shows month and income for a particular new business. What I want you doing is make a scatter plot. That includes labels. Make an equation for your trend line. Now, your trend line might not be the same as your neighbor's, and that is perfectly fine. It might not be the same as mine, perfectly fine. But I still want you to make one. Okay? So get going on it because these ones took a little bit longer. They were a little more involved. And then, if there's anyone who did not get one of these, I said those last 2 pages of the packet didn't print, so I've got them now. Okay, you just staple it onto the back of the other one, or add it into your binder, whatever your jam is.
He does not want his major design off his just label as 1, 2, 3, 4 in the graph.
Can you label it in such a way that you can do that?
Yes.
Okay.
I mean, I don't know if it's the right way to do it, but you can.
I'm saying what you just described is a legal move.
Okay.
Okay, the queen does move in that direction, yes. Just like we practiced last time, what kind of scale do you need? I've only got 10 by 10 boxes up here. Maybe my scale is going to be different than yours. Because you can use as much space as you want on your paper. As long as it's labeled and organized, as long as you follow the steps, we're good. And And speaking directly to anyone who is watching the video, apologize for part of my frame missing. Google Drive is not syncing right now, so half of my regular video screen is missing.
Oh, I thought you were getting up to
Oh, no. I'm just going to step across the hall real quick, Mr. Spear. Remember, it's not enough to just have the graph. We want the equation. Make your trend line. Follow our rules for your line. Get a couple points. Yours might be different than your neighbor's, that's fine. As long as you follow the process and you're kind of close to what I get up here, you're okay. Nice thing about trend lines is they're close enough math. I haven't seen that kind before. I'm kind of a pen klepto, so like I do not have more staples for that one. I need to get them from the office, but I've got a smaller stapler over here, and you just have to crunch it really hard.
Okay.
Who's still going on this? Because I know they do take a little bit longer. Yeah? Okay. Gone. Okay, I know that our last two or three who are working on their equation part at least have their graph, so I'm going to get that started. You keep going on your equation part. At least want to have that up here. I've got 10 boxes by 10 boxes, and I see 5 data points ranging from May to August and 1,500 to 7,500. So I personally, seeing 4 data points going from May through August, I can go by ones. I can go every other if I want to. So each one is half a month. I can do any number of things. What I really need to do, though, is be careful about my label. I can label my x-axis just month and write May, June, July, August, but then there's no numbers for an equation. So I can use these numbers right here and say X is the number of months the store's been open. It's a new business, right? I could say these numbers, and right before May is April. I could say X is months since April. I could swap these numbers out and instead use 5, 6, 7, 8 and say it's the month of the year. Did anyone use something different than those three? Who just went 1, 2, 3, 4? Okay. Who switched it over to the actual month of the year, 5, 6, 7, 8? No one? Okay. That makes what I do easier because I just want to be in line with yours. So I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But I have to label it accordingly. I have to say what it is. In this case, I'm going to say months of operation or months the business has been open. Okay, where 1 would be May is the first month they're open. Next up, I'm going to have income. I need to go from 1,500 to 7,500. I'm just going to go by thousands. I'll be able to fit up through 10,000 on here. And even better, I can even do this. How can I have just the numbers 1 through 10 up there, but label it in such a way that it works? That's it. I'm going to say income in thousands. Income in thousands. Okay. I'll go ahead and plot my points. Green. I like green. So we got 1, 1,500. 2, 3,500. 3, 5,500. 4, 7,500. I don't know about you, but that almost looks like it's not just a trend line. That looks like it's straight up a line. Okay, when you went and put your, which color? You put your trend line on there, It was almost perfect. Okay. So making your trend line, this is why I chose this problem, is this way everyone should be in about the same ballpark, if not the exact same ballpark. 1501, 2001, 75 is going to be like right. Yeah. My trend line should just be the line that goes through them. So there's the first part. Next up, I need to, what color do I want here? I'll switch to purple. Make my equation. I'll get my slope. And yes, whatever points you use, you should have gotten the same slope. So whichever one of these points you use, I'm going to go with, you know what, I'm going to go with June and July because those are my favorite months of the year. 5,500 minus 3,500, 3 minus 2 is 2,001. My slope is just 2,000 a month. Then most of you were fans of just plugging into y equals mx plus b. X plus b. So again, pick any one of these. I'm going to pick maybe the easiest point on there, the one with the smaller numbers. Say 1,500 is slope 2,000 times x was 1 plus b. Well, that's just 2,000. So if I subtract 2,000 the other side, I get b is negative 500. Put it all together, I get me a equation. Y is 2,000x minus 500. And because it was not just a scatter plot, it was actually a linear function, they should have all ended up on the same line. No matter which points you chose, you should have ended up with this. Okay? So, did you have those labeled? Did you have your axes labeled and are they reasonable? Your bottom, your x-axis should not have gone by tens. It doesn't make sense. Okay? Your y-axis probably shouldn't have gone by fives or 20s. Hundreds, if you wanted to use 60 boxes and use an entire sheet of graph paper, okay. But you should have reasonable axes. Your trend line should not just be a trend line, it should have been the line. Did you find the correct slope? Did you find the correct y-intercept? Did you put it all together to get the equation? Okay, there's your 5. And again, no matter what points you chose, you should have gotten there. Now, if you goofed your slope, let's say up here you had a negative 2,000. That's going to domino effect, right? That's going to screw up your y-intercept. That's going to have your equation all out of whack. But if you say, well, there's my error. I did all that. I just had a negative and it screwed everything up. That's the 4 out of 5. Well, I didn't really get the slope. I just kind of eyeballed it and guessed. Okay, now you're talking like a 2 or 3 out of 5. Okay? When in doubt, you can always ask. But we're 3/4 of the way through the year. You should know that by now. Anything about this? Okay. Our homework was what, like 2 problems and then more of the word stuff, like just can you recognize what causality is? So your homework, your assignment should have two decent scatter plots with trend lines make an equation. And then, does this cause that? Is there a correlation between them? Anything about it? For those that did it? Yeah. Okay. Well, I actually have it up this time. Oh, that got really big. That got too big. Why are you so big? Okay. Did you also eat your feelings? Okay. Make a scatter plot of the data pairs year in revenue. So they specifically say make a scatter plot using these two. Okay? So when you make your scatter plot, I'm going to show you how we do this in the big leagues. We stat, edit, I dump in all my data, I bring it over here because I can type it faster, and we're going to say what year since 1990? So 0, 2, 4. Frank, keep up. Frank, why aren't you keeping up? Okay, now we're good. 6, 8. Sometimes you just need a little bit of concussive maintenance. Okay, 5.7, 6.5, 7, 7.9, 0.7, 9.6, 9.9, 10.8, 11.5. Okay. Come on, Frank. Cooperate.
Halfway through doing the last question,
Uh-huh.
I realized that you gave us which function to choose.
I told you that in the review.
No, but the review was like a week ago.
Freshman. All right.
Not a freshman. Everyone else in this room probably is.
Pretty close.
Not so much.
Okay, scatter plot window. All right, if you're going to make a scatter plot for this, I'm saying X is years since 1990. I go out 16 years. You probably have, what, about 10 boxes going by twos, most likely. You went your revenue from about 5 to about 12. Could probably go by ones. Then, in the big leagues, we do that as a window, and we say I'm going to go from 0 to 16. Actually, I'll make it 0 to 20, so I got my 10 boxes go by twos. I'm going to say from 5, use my little lightning bolt to go up to 5, out to 12. I can go by ones. I can format, turn my grid lines on, and then Graphify, and you should have your scatter plot that looks like this. Okay? When you get to Algebra 2 and beyond, we never actually make the scatter plot. We just do it all in the calculator. Once you're here and you need to make a trend line, you just pick, well, I need to go as much through this data set as possible. I need to hit 2 points. I want to have about the same number of points on both sides. So most kids would probably have something like that. Maybe a little bit more up, a little bit more down. You take these 2 points, x1, y1, x2, y2. Find your slope. Once you have your slope, whatever your slope is, you plug it in here. Take your x and y, plug it in here and here. Go solve for b like we did solving equations back last semester. Now you have your equation. What made this particular problem a little more iffy was at the end they said, predict the revenue in 2012. How many years after 2012? Or how many years after 1990 is 2012?
Well,
22, right? You take 2012 minus 1990, 22. Whenever you get your equation, you now have to put 22 in for X to answer that question. That was the very last thing I said last time. Like, do y'all remember this? Sorry, I didn't explicitly say it. You can just shove X in now. And those who were listening said, yeah, that's easy. Maybe we just forgot. Okay. So just to give you an example of how that works, I would calculate. So you should have a line that was close to a third. So you should have had y is about, you would have had something like 0.35x plus 5.8. You should have been somewhere in that ballpark because this is the perfect line. Said there's a big ugly equation to get this, and the calculator does it for me. There's a big ugly equation for it. You should have been kind of close to this. Well, if I know this, then I can just come back to my main screen here. I don't want that. Get out of there. And I can say about 0.35 times 22 years plus 5.8. Frank, you 0.35 by 22 point plus 5.8. Jeez. Okay. My computer is acting all kinds of stupid today. Like Google Drive hasn't synced completely. My video is missing parts of it. It's being slow and laggy in different areas. It's acting like the new laptops. So, any of you who were in here last semester, you remember how much I fought with that thing at the beginning of the year. God, these new laptops are trash. They're so slow. But the other one that you did was pretty much the same thing. Go make your scatter plot. Once you have it, can you predict things? Once you have an equation, can you predict? Everyone's got their packet or their handout, their last two pages, 5.8. 5.8 is actually super simple. Very, very simple. In fact, you should have time today to work again, so no math homework going into a weekend. So, let's do it. Okay. We're going to talk about absolute value transformations. Okay, I think that's delightfully ironic today. You know, happy TDV to those who celebrate. We have, if I take line 1, how can I slide it to line 2? Like, do you remember doing picture, like, slide the triangle around kind of stuff in middle school? They called them transformations, right? You would take this image and move it so many units to the right, so many units to the left, that kind of stuff. How can I turn blue line into orange line? Down what?
down 1 point something. Oh, down 1.
Maybe if I make it bigger. Womp.
Oh yeah. Down 2.
Okay, it is 2. They only wrote the 2's there, so you're like, oh, they're going by 2's, but it's on the second box. Okay.
Oh.
Watch that. You better watch that. My Algebra 1, oh boy, do they get caught by that scale every time. Yeah, it went down 2 units. But you notice that every single point in it goes down 2 units. That's what a transformation is. A transformation is I take what's called a parent graph, a parent function, and I alter it. Case in point, I've gotten to meet some of your parents. And holy crap, are you a clone of your parents? Okay? Gillian's like literally mini-me of her mom. It's adorable. Okay? Like Sophie and Jacob, you two might as well be twins. Okay? You get that transformation of genetic code where here's the parent, here's how it starts, what do you do to it? How do you alter it to make this one? And it could be something as simple as shift down 2 units. Okay? But we're going to get some big kids words with it. We call it a, do you know what the word is for up and down? Vertical. We call it a vertical translation. What if it shifted left, right? Horizontal, right? The horizon. Those would just be a combination. I would do a horizontal and vertical to go that direction. And that's something that you can also do with this. Everyone pretty much locked in on it shifts down 2. Could you do it a different way? If I'm going from line 2 to line 1, that's shift up 2. There's another way to go from line 1 to line 2 besides just up down. Oh, now you're going to separate them? Yes. Okay, there we go. Right? There was a horizontal translation of right 6. You could have either done down 2 or right 6, and they both would have ended up in the same spot. So that's what we talk about today, is this idea of translations can move left, right, up, down. That's the big kid word for I slide it. That's probably how you did it in middle school. I slide it or I shift it. We're going to use big kid words now. It's a translation. I shift this over to this. How many of you are in Spanish or French right now? A translation. It doesn't just work like Google Translate says, does it? How many of you try and do your homework with Google Translate? Uh-huh. You can't just type it in and it spits it out and yeah, that's the direct translation. Do you know that's why so many of our historical texts are messed up? Okay? Who here is part of a large denomination religion? Christian, Jewish, Hindu, Buddhist? Most of those texts are written in other languages and they were translated from maybe original Hungarian into German, into Latin, into Old English, into modern English. You know what happens? You ever played the telephone game? Right? You whisper the thing and then the person draws it and then the next person has to write and say what it is, and that by the time it gets to the end of the table, it's not even close. Think about that. The historical texts that a lot of people base their lives on, they were translated like that multiple times. Okay? You can translate something left, down, up, right, but math is a lot more concrete. In fact, if the number's in this spot, it does this thing, end of story. Thought end, math is math. Mr. Incredible meme, okay? The one that we're going to work with is absolute value functions. Do y'all remember absolute value from first semester? What does it mean? Ooh.
What's the absolute value?
Okay, absolute value will always be the same, whether it's positive or negative, because absolute value is the...
Is the opposite of, it's like the overall.
Thank you, someone with the notes from first semester. What is absolute value?
The direct distance from 0 on the number line.
Well done, freshmen. Take out your headphones, but well done. Okay, distance from 0, right? If it's 11 miles from my house to the school, does that mean it's negative 11 miles from the school to my house? No, 11 miles is 11 miles. Unless you're insulting someone, you can't say you are negative 4 feet tall. Okay? Because you can't have a negative length. This means if I try to graph something and I say the absolute value of 1 is 1, the absolute value of 2 is 2, the absolute value of 3 is 3, but what's the absolute value of negative 1?
1.
Also 1. What's the absolute value of negative 2? Absolute value of negative 3. What's the absolute value of 0?
0.
Absolute value graphs look like a bunch of V's. Because all of this stuff down here that would have been negative is all positive now. So it takes that line and like kinks it upward. Okay? So they're going to ask, how are these two graphs related? How did I get from here to here? And we're going to use big kid words for it. I took this graph, whoop, and what did I do to it? It moved down 2. So we're going to say that there was a vertical translation down 2. Big kid words. Now, you've been here long enough to know that I don't put vocabulary on tests, but boy, you better know that vocabulary, because if you don't, then you have no idea what the question's asking you. Okay? A vertical translation down 2, because every single point on this graph moved down 2, moved down 2, moved down 2. All of them will move down 2. Okay? So, nice and simple. This, you notice they're saying y equals absolute value of x again. This is called the parent function. It's the template. It's the base model. Okay? I dare you to go home and tell your parents that they're the base model. Your version 1.0. Okay? That's what all absolute value functions start as, and then, by something that our school refuses to tell you in any of your health education classes, that genetic code is modified, and the result is you. So, you tell me, how do you get from that function to this? But use your big kid words. Just write it next to it. What happened? Well, they do. It just slid over, so it's some form of translation. What kind of translation? How far? What direction? Wrong pipe.
So it's not showing us two lines to compare. It's showing us the line and the.
Okay, because you now know that this looks like this. Damn it. You now know that this y equals absolute value of x looks like that. That's the parent function.
Okay.
How did I get from here to here? Okay, it's like every 2 years or so when another Reddinger kid shows up in my class. Like, I've sat with those parents at conferences for the last 7 straight years. there's like 9 of those kids or something. They got a lot. Okay. And every time one comes in, I know their parents pretty well now, and I see a kid who looks like mom and dad. I know. Right? I see a V. I know who your dad is.
There's like 4 more of them.
I know. I think Aubrey is somewhere in the middle, and she was the last one I had in here. All the way up to, who was the first one?
Caleb.
Jake. I had Jacob. I don't know if I had Caleb.
Caleb or Erica? You had Erica?
I think I might have had Erica.
You would have had Erica, I'm pretty sure.
I might have had it, yeah. I know I've had 3 of them.
She's in Finland now.
I'm gonna add you to the list with the other ones who are making me feel old.
She's in Finland with 2 kids.
God. It's fighting dirty.
She's not just in Finland.
You just stop it. So, what did we do? I know it's some form of translation. It went up, so I say it's a vertical translation up 2 units. Now, 2 units, scale of 2, up 4 units. The other one was 2 units. This is 4 units. Vertical translation up 4 units. Now, mathematicians are notoriously lazy. What happens is after doing those a few times, we start saying, vertical translation up 4 units. Vertical translation up 4 units. Okay? Now, we do start doing that, and we're getting lazy. You better know what the real words are. What I don't want to happen is you to keep writing this in your assignments and your daily quiz, and then what happens if on the quiz, like in parentheses, I specifically say write out the entire terminology, and you forgot what that meant. It's a VT. Well, what's VT? Is that the other thing in health class they use to scare us? Like, no, vertical translation. You got to know what the words are. All right. It asks, what are the domain and range? Do you remember those from all the way back? What was that? The beginning of this semester? Domain and range. Does anyone remember what domain means? Or could look at the beginning of chapter 4.
It's input output.
Okay, domain and range is input, range, output. In terms of variables, they are the x's and the y's. What I can control, what comes out of it. The chicken I throw in the machine, the nuggets that come out. Okay, input, output. So domain. Domain is like a list of things that I am not allowed to do. Who's not allowed to my party? Okay, if the one rule that I have at my party is don't eat my goldfish, well, Ryan Potter is not allowed to come to my party because he used to eat our goldfish. There's literally my friend, my freshman year of college. He ate my now wife's goldfish. Come to her apartment, and he just like a cat out of her fish tank. And he just sit there going, I can feel it. Because it was still swimming in his gut. He was a different character. That is my one rule. Don't eat my goldfish. Who's not allowed to my party? Potter. The rules that you know so far in math are, I'm not allowed to divide by 0. That breaks math, right? Try take any number you want. Try 0 divided by 0. You got a calculator. That should work. They're both zeros. It says domain error. You can't do that. It broke math. You have violated my rules. You ate my goldfish. Therefore, it would not be allowed as part of the domain. But in this, Do you see a variable anywhere on a denominator? There's nowhere that I might divide by 0. If I had something like 3 over x, well, now if x was 0, I would be dividing by 0. That's not allowed to the party. There's nothing like that in here. My x's go all the way to the left and all the way to the right. So everybody is allowed to this party. My domain is going to be all real numbers. You remember that symbol? It's kind of like a blurry double R. All real numbers are allowed to this party because all of the x's exist. But look at the graph. Does the graph hit all of the y's? Did the graph ever hit 1 for a y? Where did it start existing? The y's. Where did the y's start existing? At 4, and everywhere above that. So for my range, I'll say y is greater than or equal to 4. Remember our inequalities from first semester. My y's can be 4 and bigger. My y's can never be lower than that. Okay, think about it like the function machine again. What this is saying is I'm allowed to throw anything in the chicken nugget machine, but I'm only going to get out nuggets. I'm not going to get out pizzas. Okay, it's not going to give me anything below that. It'll only give me this stuff. If it's a nugget machine, it's only making nuggets. It's not going to make squeeze tubes of Go-Gurt. Okay, like it can only give me stuff 4 and bigger. That is its purpose. So domain and range, those are coming back to us now. Uh-oh. Now they want us to graph it ourselves. We got 2 ways to do this. Way number 1 we learned back at the beginning of the semester. That would be make a table. If I got no idea how to do this, I can always make a table. We pick the easiest numbers right smack in the middle of the graph. -3, -2, -1, 0, 1, 2, 3. And let's start at 0 in the middle and kind of work our way in both directions. If I put a 0 here, how far from 0 is 0? 0. Plus 2. Cool. What if I put a 1 in there? What's the absolute value of 1? 1. Plus 2.
3.
I put a 2 in there.
2.
Plus 2.
4.
What's happening?
It's just going up.
I'm just going up by 1. Okay. But what if I put a -1 in there? It's still 1 plus 2. It's still 2 plus 2. Stop it! Freshman. Okay? It's going to do the same thing, but on the other side. And if I plot those points, it turns out I didn't need this table at all. Because this tells me it's going to move up 2. And then, because the parent graph always has a slope of 1 on the right side and a slope of -1 on the left side, I don't actually need all of that table stuff if I know how the parent function is. Okay. Now, naturally, you can always make your table, get those points, and then connect the dots. Okay, that is your fallback option. All the way into pre-calc, I have kids who they graph by table. Now, we let the calculator do all the table work for us, but we're still graphing by table. Okay? So if you need to use the table to plot the points, you go right ahead. I want you to graph the that. I don't like you going off-road that far. Change your scale to go by twos. Your y-axis to go by twos.
So, parent functions, are they always?
Mm-hmm.
They will never be.
The parent function never will. We learn different transformations throughout math that will make it do that. But right now, no. The parent function is always
So-
positive e.
You don't really have to do domain and range, you just know that it's 7 and then it's this way.
Well, your domain will be all real numbers because my x's go both directions. And your range will be what's the lowest that the y's ever go.
So isn't
And
that
up.
right then?
Yep. Close. If I say times 2 here for my y-axis, my slope needs to be correct. Right now your slope is off.
What do you mean?
Make the table, like leave that where it is right now. Make the table and see how it compares. Yeah. Yeah. Yeah, don't want to miss those. All of these as absolute values are all positive, right? So 0 minus 7, 1 minus 7, 2 minus 7, 3 minus 7. Absolute value of negative 1 is still 1. Minus 7, minus 7, minus 7, minus 7. So here's why that table might not be a bad idea, even if you think, well, it's just going to look like this. If I go by twos, here's 1, 2, 3, 4, 5, 6, 7. If I plot all of my points now, this is at 1, negative 6, 2, negative 5, 3, negative 4, 4, negative 3. Because I had to change my scale, you shouldn't have that sharp upward V. It should look a little more squished because each box is worth twice as much. Okay, think about grabbing the corner of a picture that you're editing and stretching it one way or the other. Okay, this one is going to get squished because of that scale. But actually hit the dots. So, I'm going to give you a cheat code for these as to how to always graph them like our lines. Is that what the next thing is? Horizontal translation? You know what? I want to do these by table first so we can talk about how it's affecting it. I start with, Here's a X, here's a Y, shoop. And we're going to go, because I know what's going to happen, let's do -10, -8, -6, -5, -4, -2, 0, 2. Trust me. I'm going to show you the tricks for it later. Right now, I'm just going to say use those numbers. What's up?
Just out of curiosity, why can't it be a 5 as well?
We'll see.
Oh, because it's a +5?
There's a method to my madness, and yes, it's because of that +5 up there. Okay? So, you. Jam a -10 in there. What is -10 plus 5? -5. How far from 0 is -5?
5.
Okay. Jam a -8 in there. -8 plus 5.
3.
-3, absolute value is +3. Fill out the rest of the table. Now, do you see why I went by 2's, but I included that 5? All right. My x values are way too big to fit on this graph, so what can I do? I'm going to make this go by 2's. Then, -10, 5. -8, 3. -6, 1. -5, careful, it's halfway, 0. -4, 1. -2, 3. 0, 5, 2. Off-road. You see why I picked those numbers? Because now I can actually see the entirety of my graph. Connect the dots. And that V point, called a vertex, is at 5. -5. Not +5, -5. Huh. There's something there. There's a thing there. So I'm going to have you do it one more time by table. And I want you to see if you can figure out the pattern here about what's going on. You choose whatever points you're going to choose, but you have to be able to see the V. I recommend choosing positive numbers. I'm just going to put a whole bunch of numbers on there. Oh, maybe I picked dumb numbers. But I'm just going to pick numbers. Hi.
Do you have something I can get a silver out with? Well, I'm guessing you have to use.
Don't hurt yourself.
Oh.
Tools are tools. Okay. If I jam a -4 in there, -4 minus 5 is what? And then absolute value. Put a -2 in there. And then, curious, how many of you make your 7s like that with the little line in there? Okay. Every now and then I run across a kid who still does that. And I heard, I don't remember who the teacher was, I've had a couple of kids tell me that they had a teacher yell at them for doing that. Like, I will count your stuff wrong if you do that. That just ain't right. Stick a 0 in there. 0 minus 5 is -5. Absolute value of -5 is 5. Stick a 2 in there. Stick a 4 in there. But what happens when I get to the other side? Now I'm at 6. 6 minus 5 is 1. Absolute value of 1 is 1. Stick an 8 in there. 8 minus 5 is 3. Absolute value is 3. Absolute value is 5. Absolute value is 7. I do not have enough room to put all of my points on there, so I'm going to go by 2's again and say, where are you? 4, 5. Okay, womp, womp, womp. Oh wait, we went by more. Okay, so we have -2, 7. I don't got enough. 0, 5. I got enough for that. 2, 3. I got enough for that. 2, 3, not 4, 3. Going by 2's. Jesus. Okay, 4, 1. 6, 1. 8, 3. 10, 5. You can see where it's going, right? What happens if right here I stuck in a 5?
It would be 0.
Mm-hmm. Because it's right halfway in between there. These things are symmetrical. Y'all remember doing symmetry stuff in your art and math classes before? Okay. Wherever that vertex is, it's going to, like, butterfly effect on both of them. Yeah?
Will absolute value always be the...
Yes. That's the parent function. Now, if the parent function is of absolute value of x looks like this, I can start monkeying with it. I can stretch it. I can compress it. I can reflect it. I can translate it. So maybe it looks like this instead. If I absolute value the y instead of the x, and that starts getting really weird. Okay. I want you to look at these two graphs. I want you to look at their two equations. Okay, 1 through 5, 4, 5, and then we went by. Okay, look at the two graphs you made. Look at the two equations. They both said something 5, but they both did something different. Can you come up with a theory as to what that number inside the absolute value does? What do you think?
Oh, I did. It's okay. It horizontally transitions it 5 over.
Okay, the number inside the absolute value will do a horizontal translation. Which way?
The opposite.
The opposite. Go back to the previous page. We had numbers outside of the absolute value. Those were all vertical translations. Which way? If it said +4, we went up 4. If it said +2, we went up 2. If it said -7, we went down 7. This is something that your book will not tell you. This Algebra Half curriculum will not say this, but I'm going to tell you because it's so much easier. Right down here, I want you to write the cheat code. Okay? Cheat code.
Well,
Okay.
anyway, I ended up with like a linear line.
Forgot to do absolute value after.
No, I don't think I did enough points. Do you think that would make it?
Yes, because if your points, like say you didn't do a scale here, and you only went out to 5, all you saw was that. We might have goofed something then with our absolute value. Okay, I'll show you the cheat code and how much easier this gets. Y is absolute value of x minus h plus k. H is inside the absolute value brackets. Inside the absolute value, grouped with x, is bass-ackwards land. That is our horizontal translation, and it's always backwards. Now, why would it be backwards? Well, x is, we said it's our domain, it's our input. I want you to think about a good number of you are either just now starting to or have recently started or looking forward to driving and having your own car maybe. Well, you're saving up for your car. It costs $2,000 to get your car. I'm saving up money. I got my job, I'm setting aside money for it. It takes $2,000 to get to car. Well, what happens if I say, and I take $200 away from you? You broke your phone and your parents said you got to buy your new one. Is car closer or further away now? Further away. So when I said minus 200, my goal, my output, went that way. What if I'm saving up for my car and grandma sends me a fat check for my birthday? My goal just got closer instead. So that's why whatever's inside the grouping, because it's with my input, has an opposite effect on the graph. If they say +5, I go left 5. If they say -5, I go right 5. Inside the grouping is bass-ackwards land. But outside the grouping is regular land. And that tells me go up or down. That's my vertical translation. And then we're not going to mess with any stretch or compression or reflection in here. Okay, I know Amy's a little concerned about that. Like, could it flip? Could it do this? Could it do that? You don't have to worry about stretchers and compressions yet. That's later in math. I'll tell you that the slope on the right side is always 1. So this, for example, I see a -4 in the grouping. I see inside negative. Tells me I'm going to go right 4. So I know that I'm going right 4. I see a +2 outside the grouping. It tells me go up 2. That tells me my vertex, the bottom of that V, is going to get moved right 4 up 2. So I'll go right 4 up 2. That's the bottom of the V. That's my vertex. And then the slope on the right-hand side is going to be 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. What does it always do on the left side? It mirrors is to, instead of up 1, right 1, up 1, left 1. Up 1, left 1. Up 1, left 1. Up 1, left 1. There's my V. Uh-huh. I want you to. Transformations are so much easier. You don't have to do it by table. If you know this, all the graphs are going to be the same. You just move it up, down, left, right. So do those two. Those two right there. Move your V left or right, up or down, according to this, the holy grail of our transformations. Uh-huh. Both of you are guilty of it. You think I don't notice.
Why are you just telling us this now?
You got to learn how to wash the dishes before you're allowed to use a dishwasher. How upset would parents be if I told both of you to stand up and do a hand check right now? And then those particular phones disappeared and they had to come get them. Fix your behavior before I have to fix it for you. We lost those privileges. Okay, so just move the vertex, the bottom of that V, left or right, up or down, based on that cheater. Where is... God, this thing is running slow. Holy smokes, there's a lag on there. I'm trying to find my holy grail. I don't, since Google Drive isn't working, I'm having to find it through through our videos instead. Holy crud, this thing is really slow. Okay. All I need to put next to this is it's +1 in the grouping. That's a horizontal translation, left 1. It's a -3 outside the grouping. Tells me that's a vertical translation, down 3. So I'm going to take the V that would have been here, my vertex, and I'll move it left 1, down 3. And then from that point, on the right-hand side, I'll make my slope 1. Up 1, right 1, 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 up 1, right 1. I will not connect the dots all the way down as a line because it's a V, not a line. So I will then mirror. Up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1, and I got a V. Okay? Left or right, up or down. Same thing here. I know I'm going right 2 and down 5. Horizontal translation, vertical translation. If I go right 2, down 5, and then my slope is 1 on the right-hand side, make sure you're using points so you actually hit those intersections correctly. Now, your graph might look more like a check mark than a V because we're moving it way out in the middle of who knows where. So I only see part of the graph. Remember, if I had more of the graph, wouldn't this continue and make a full V? Yeah, that's why we put those arrows on there. I'm just saying, don't be alarmed if you only see a check mark instead of a V. You're just seeing that part of the graph. So I hope you got that little cheater written down there because it makes this work so much easier. Instead of having to use a table, which sucks, you just move it over here, slope is 1. You're done. Okay. The last thing that we got are what's called step functions, or sometimes they're called greatest integer functions. Okay. In fact, we should probably write that up here. Greatest integer functions. Okay. Greatest integer functions. So first of all, do you remember what an integer is? Like chapter 1, lesson 2. Some form of number. You remember all of your different number realms? There's the natural numbers.
That's a
Negative and positive.
no decimals and fractions.
No decimals or fractions. Negative and positive whole numbers. Okay? Remember, there's natural numbers. That's counting on your fingers and toes, Alabama math. There's whole numbers where you also include 0. 0, 1, 2, 3, 4, 5, da, da, da. Integers are where I go dot, 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 -3, -2, -1, 0, 1, 2, 3, dot, 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 dot. Terminating and repeating decimals or fractions, those are my rational numbers. Okay? Greatest integer function, you do not copy this part. I'm just explaining what it means. At 0, don't copy this part. What is the biggest number you've ever seen when you're at 0? 0. Okay. So what's the biggest integer you've ever seen when you're at a half? No, integer. Biggest positive or negative whole number that you've ever seen when you're at a half? Still 0. The biggest number I've ever seen, the biggest integer I've ever seen when I'm at 0.9999999. Still 0. But as soon as I hit 1, what's the biggest integer I've ever seen? 1. Do you remember putting open circle to mean not here, closed circle to mean yes here? We did that with our inequalities on number line. Well, now I'm here. What if I'm at 1.3? What's the biggest integer I've ever seen? What's the biggest integer I've ever seen? Biggest integer I've ever seen. As soon as I'm at 1.99999, what's the biggest integer I've ever seen? Still 1. But as soon as I hit 2, open circle, jump up to 2. As soon as I hit 3, jump up. As soon as I hit 4, jump up. As soon as I hit 5, jump up. As soon as I hit 6, jump up. If I'm at 6.829, the biggest integer I've ever seen is 6. But as soon as I hit 7, it's 7. This is what a greatest integer function looks like. And do you see why they call them step functions? It just looks like a flight of stairs. Okay? So I bring that up because in the context of this problem, we're going to have to use that idea. A school is going to go pay for a bunch of buses so they can have the entire student body go to a football game. Everyone's going to go. Each bus holds a maximum of 60 students. Make a graph that models the relationship between students and buses. So, think about that. If I have 0 students, how many buses am I getting? If I have 29 students, how many buses am I getting? 1. As soon as I have 1 student, how many buses am I getting? 1. As soon as I have 58 students, how many buses do I have? I got 60 students. How many buses do I have? 1, because the capacity is 60. And then, the second I hit 61, how many buses do I have? All the way up until I'm at 119 buses. 109, that's a lot of buses. 119 students. How many buses do I have? Still 2. Because I haven't, remember, 60 kids per bus. 60, 120, 180, 240. So at 120, I still have 2 buses. As soon as I hit 121, now I'm at 3. If I'm at 180, I'm still at 3. As soon as I hit 181, now I'm at 4, right? It's going to give me this step function where I should probably go by 60s because that's the capacity of my bus. 60, 120, 180, 240, 300, 360, 420, 480, 540, 600. Which actually ain't too far off. I think our, oh no, we've had an increase lately. Your class. I think Spearfish is up to, what are we at now? Like 720, 750? Okay.
About 420, 480.
420, 480, 540, 600. Going by 60s. And then right below that, I don't have room and this won't write on the bar. You're going to write number of students. On the side, you're going to write number of buses. And 0 buses, 1 bus, 2 bus, 3 bus, 4 bus, 5 bus. A step function will say, anytime I'm from 0 to 60 students, At 0 students, I have 0 buses. All the way until I hit 60, I have, oh, wait a second. As soon as I had a student, I had 1 bus. So that part doesn't need to be there. At 0, there is nothing. That's why there's an open circle. 0 students, no buses. But as soon as you hit 1 bus, or what do I keep saying bus? As soon as I hit 1 student, I now have 1 bus. All the way until I hit 60 students, I still have 1 bus. As soon as we jump up to 61 students, I've got 2 buses. All the way to 120 kids, I'm still at 2 buses. But as soon as I go to the next kid, 121 kids, I'm at 3 buses. And then 4 buses. And then 5. And then 6. And now I have the pattern where I get to fill this all in. And if I were to ask you the question now, in grades 10 through 12, I have 538 students. How many buses do I need? I'd go 538 is right below this, 9. I have 541 students. How many buses do I need? Now I need 10. Okay? I mean, A, we've all done that. B, that's illegal. Like, it's illegal to do that. That's why they have a capacity on the bus to sit in the aisle or to pack like 6 kids to a seat. Or who's been the kid who's been crawling up on top of the seats and then the bus driver brake checks you? Okay. This one right here. Okay, this is just more practice, but this one. You're all packing up. We got about that minute and a half left to finish off this section of notes. I want you to do one more, except now they're going to say the bus holds 50 students. How are you going to make that graph? Okay? Finish it off. You can power through it right now, or you can pack up and you got to do it as part of your assignment. I don't care, but it's got to be done.